All right, hello everyone. Today is 3.3. It's rate of change in slope. It's a pretty big lesson, so I'm going to move fairly quickly. Just a reminder to pause the video at any time that you need extra time to copy down the notes. Your two vocabulary words are rate of change, which represents the change in y over the change in x, and slope describes how steep a line is. Make sure you get those down in your notes. Let's get started right away. Rise over run, if you remember that from last year. Is the same thing as the change in y over the change in x. So if they give us a table and they ask us to find the rate of change, what I always do is I start at the bottom of my table and I work upwards because I don't like to deal with negative numbers. And I say 228 minus 152, well that happens to be 76. Well, 152 minus 76 is also 76. So my y values are 76, my change in y, and my change in x, 6 minus 4 happens to be 2, and 4 minus 2 happens to be 2. So each time x increases by 2 hours, y increases by 76 miles. The next slide explains it. So rate of change, we have the change in y over the change in x. In this situation, it represents distance over time. 152 minus 76, and we said 4 minus 2 represented 76 over 2, which can be simplified to 38 over 1. Well, what does that mean? It means that the rate of change is 38 over 1, which means that the car is traveling at a rate of 38 miles per hour. Let's look at the next one. The table shows how the cost changes with the number of minutes used. Use the table to find the rate of change. Explain the meaning of the rate of change. So the change in y over the change in x. Well, I'm going to look at my y values and I'm going to move upwards. So 3 minus 2 I know is 1, and 2 minus 1 is also 1. So my y's are increasing by 1. 60 minus 40 is 20, and 40 minus 20 is 20. So my rate of change is 1 over 20. Well, what does that mean? It means that for every dollar, it represents 20 minutes of talk time. And this graph is going up by a constant speed. So I could assume that 4 hours would represent 80 minutes used. I'm sorry, $4 would represent 80 minutes used. And $5 would represent 100 minutes used. So this is the answer for the rate of change for the table shown. Variable rate of change. Sometimes we look at graphs and we want to know what the rate of change is between a very specific part of your graph. In this case, they want us to find the rate of change for 2002 to 2004. Well, X is my years, and my passports, number of passports in millions, is my Y values. Well, my change in Y's from 2004 to 2002 is 8.9 minus 7, which happens to be 1.9. And my Y's, my change in years, happens to be 2004 minus 2002, which happens to be 2. So in this situation, we're going to use the formula for slope, rise over run. So passports over years. I copied the graph again to show you that 8.9 minus 7, we did that. We got 1.9 over 2, and it simplifies to 0.95. Now, what does that mean? Well, it means that the number of passports issued increased by 1.9 million in a 2-year period for a rate of change of 950,000 per year. Our answer was 0.95, but remember it says right here that 0.95 is represented in millions. So 0.95 translated to 950 passports per year over that 2-year period. All right, this question will be answered on the Google form. This is your multiple choice question. So I want you to do the same thing. You have two problems here though. They want the rate of change between 1995 and 2000, and then they want the rate of change between 2000 and 2005. So go ahead, take your time, answer, and find the rate of change for both of these, and then save your answer for your Google form at the end of the video. All right, constant rate of change. Constant means that it's increasing or decreasing at an exact same speed or time or distance, whatever we're representing. Now this next example is just a table with X and Y values, so we don't actually know what we're talking about or what it's representing, but we want to know the change in Y over the change in X. So in this case, 12 minus 6 happens to be 6, and 2 minus 1 happens to be 1. So my rate of change is 6, or 6 over 1. 18 minus 12, and the same thing, 3 minus 2, I did the same thing here. For my next set, I also get 6 over 1, or just 6. And again here, 24 minus 18 over 4 minus 3 happens to be 6 over 1. So what does that mean? It means that it is a constant. If you get the exact same number for each representation of x over y, the function is linear.